So, good morning, everyone. So, welcome to the session, Reduce Cost by Tuning Queries on Azure Database as a Service. Okay, please silence your cell phones. Okay, so apart from this big PaaS conference, PaaS offers many other things like 24 hours of PaaS marathon, local user groups. So you can explore more on their website. Please submit the session evaluation. This is very important, especially like speaker like me. So kindly submit the evaluation. Okay, so I am Rajnikant Tandel. I am a SQL Server DBA and DBA manager at Datawell. And I have been working for Datawell for 12 years, and my overall experience in IT is close to 20 years. I started my career as a programmer, and I did a lot of programming in beginning of my career, and then moved into database space. So on the SQL Server side, I started with SQL Server, so you can imagine I worked on many projects, starting from database development to HADR solution, but my interest area has been always performance tuning. And I like to run half marathons. Okay, so if you migrate your SQL Server database to Azure or any cloud, do you think your performance problems will go away? No, right? Yeah, there is an automatic tuning feature available in Azure, and many people think that once you move to Azure, you don't have to worry about anything. All your automatic tuning feature takes care of everything. But that is not the case. Automatic tuning feature that is very good at recommending indexes and finding the queries which are costly queries, but it's not going to tune your queries. So in this session, I am going to talk about some query tuning techniques and how to reduce the cost using those techniques. So before going over my agenda, I just want to talk about how I came up with this topic. So I work at Datawell. Datawell is mainly a managed database service provider. So Datawell supports many databases like SQL Server, Oracle ABS, MySQL, Mongo, any database. So one of my DBaaS clients, they moved to Azure around 6 months back, and they went with a very high pricing tier, like they were paying around $8,000 per month, but they were not happy with the performance. So they asked my DBA to look into it, and after a couple of days of finding, my DBA came up with 2 queries that has implicit conversion happening. So he suggested to correct the data type for 2 queries, a data type of the variable for 2 queries, and client implemented that, and within a flash, DTU came down to 10%, which was always hitting 100%. So then they observed the performance for a couple of days, and they lowered their pricing tier, and that was costing them $1,700 per month. So they were saving $6,300 per month just by changing 2 variables data type. So that comes to yearly around $75,000. That's huge. So I thought, just like implicit conversion, there are like other scenarios that can also help with performance as well as reducing the cost of your database. So that's how I came up to this topic. Also, when you have a server on-premise, so that the process for setting up new server starts with capacity planning, and then buying hardware, then purchasing licenses, then installing everything, and then you tune your database or your application if required. And even if you tune your database, you won't be able to save the money because you have already paid for the hardware. While Azure, when you pay for a capacity on demand, you always have a chance to lower your monthly bill by tuning the queries or reducing the resource utilization. So actually, any query running on Azure that is not running optimally, that means that is costing money. So if you tune them, you can lower your monthly bill. Okay. So I work on many performance tuning projects, and many times I interact with the developer, and they think that query tuning is very hard and complex, but it's not that hard. It's just an art of writing a query in such a way that it accesses minimum number of pages to get the result. Like suppose if you have 1 million rows table, and if you want just query 100 rows, you should write a query in such a way, or your index should be in such a way that it should touch only those 100 rows. Pages belong to those 100 rows. So that's how it should be efficient. Okay, so coming back to my agenda, so I'm going to run load on my Azure database first. That will run all untuned queries, and then I will run the load again with the tuned queries, and then I will lower my pricing tier and then run the load again. And when these loads are running, I'm going to talk about these 8 query tuning scenarios. This is going to be more demo heavy. I'm going to show demo for each and every one. And for demo, I'm going to use this credit card database. So credit card database has 4 main tables: a member which has a member number as a primary key, category, this is like a lookup table, provider has a provider number as a primary key, and charge has charge number as a primary key, and provider number, member number, and category numbers are foreign keys. So charge is basically transaction table. Okay. Go back to slide, and these are the query tuning scenarios I am going to talk about today. So let's start with the is null. So sometimes we use is null for no reason. I have seen usage of is null in a query when column is declared as not null. So if it is not null, why do you need to use is null on a column? So if you use that is null on a select clause, select column list, that is fine. But if you use that on a where condition or any filter condition, that's going to cause a problem. So let's regional syntax. It has 2 arguments. First argument, and when first argument is null, it's going to return the second argument. Otherwise, it's going to return the first argument. So in this select is null weight, 50. So it's going to when weight is null, it's going to return 50. Otherwise, it's going to return weight. So let's look at the demo. So here is my credit database. Let me switch on this statistics IO on, and also the execution plan. So most of the time you see query written like this, where is null, we convert is null crop number, 0 equal to crop number. So if I run this query, so if you look at the execution plan here, you see the index scan here. And if you hover the mouse here, it shows that actual number of rows 50 and number of rows read 100,000. So it's doing the index scan here. Just because of this is null, we are using is null over the column. Now suppose if we pass 0 here and same thing, then also it's going to do the same thing, index scan, and if you see that it's scanning reading the 100,000 rows. Okay. So if I write the query like this without use null, I'm just passing that crop number 377, and if I write the query like where crop number equal to. So by the way, this is visible, good enough? Okay, good. Okay. So if I write without is null, if I write the query like this, then it's going to do the index seek here, and if you hover the mouse here, it's reading just 50 rows. And so why, I mean, if I pass null here now instead of 377, then it doesn't return any rows, because when set NC null is on, any data comparison with null evaluates to unknown. So that's why it doesn't return any rows. So if we do the here, suppose here is an example, if we do the null equal to null, it's going doesn't return anything. But if I do the set NC null, I have to make it off. If I make it set NC null off and then I run this one, then it's going to return the 1. So when it is off, that any comparison with the null evaluates to true. So let me switch it on again. Okay, so now here is another example that says, suppose corp number we are passing null here. So what we are doing is checking the is null condition on a variable, whether variable is null or not. Based on that, we write this query. So if it is null, and if it is this is true, so if it is null, then it's going to be 0, then it's going to run this query. So in this case also, it is doing the index seek. So it's scanning just 100 rows, reading just 100 rows. So we have two scenarios. One is if it is not null, then we can use this query, this one. So we don't have to do use null. And if it is null, then we can evaluate the variable here and run the query like this. So in the both case, it is doing the index seek. If it is unseen null is off, then in any condition, it's going to do the index seek like this one, or even if you pass the null here, then also it's going to do the index seek. But we usually in the most of the environment, I have seen that unseen null is on. So to combining the two queries, just evaluate the variable here first. Like if its variable is null, then write it not null, then write this query. Otherwise, this is, if it is no something okay. If it is null, then write this one. Otherwise, this one. So in a one query, even if you pass here, suppose if you pass 377 here in a corp number, it's going to return. It's going to do the index seek. And if you pass the if you pass 0 or null here, then also it's going to do the index seek and scanning just 100 rows. Okay, here is another example. So sometimes we say this is going to return data when region number equal to 1 or null. So I'm converting each null region number comma 1. So comparing with that one. So if we do this way, this is going to do the index scan. If you see that number of rows read, it's 100,000. But instead of that, if you write a query like this, where region number equal to 1 or region number is null, then it's going to do the index seek here. Okay. Or another way of writing the query is select star from, we can do the union all, and this one query is select star from member where region number equal to 1 and select star from member where region is null. If you run this query, so in both cases, it's doing the index seek because of two queries are here, so it's doing the index seek on both the times. So instead of using is null over the column, you can first evaluate the variable and write the query based on that one, or you can in this scenario you can do the union all, or you can write the or condition. So that way you can avoid the is null, and that is null is going to scan the table. Yes.
Is null uses the index seek, right?
Is
region number is null will use the index seek.
Index seek, yeah.
Right?
Yeah. Yeah, even this null. So if you, let me just show you one more time. So here, this one, even if it is null, it does the index seek. Yeah, correct. So basically, just writing the query. You can write 2 queries, or you can just avoid the is null over the column. Keep the column alone. That's the main thing here. So that way, you can use the index properly. Okay. So when you use the is null, that is forces the table scan, and that we've seen. So one option is you can set the default value on a column. So when suppose there is an integer column, you can set the default value to 0. So in that case, you don't have to use the is null. So you don't have to worry about anything. But when you set the default value, that's going to occupy some disk space, because for integer, I think it is 4 byte. So when you, and instead of null, if you store 0, that's going to occupy 4 bytes. But even with the null, SQL Server uses null bitmap to check that whether column is null or not. So that also takes 1 byte actually. If it is a null value, then SQL null bitmap is 1, otherwise it's 0. But that also takes 1 byte. So you are saving actually 3 bytes. But I would say rather than saving the disk space, we should concentrate more on a performance. Okay. And you can always evaluate the variable value first and then write the query. So any question? Okay, I'm not, because of this one I cannot see this side. Okay, then let's move on. Second topic, when to use between over in. So we know between and in. Between selects data within the range. So and begin and end values are included. So it's like a from date to date or from number to number, and in you can specify the multiple values in a where condition. I have given 2 examples. Those are we can use we use this daily. So let's quickly look at the demo for between and in. Okay, so here is a simple query. I'm doing select star from member where member number in 1, 2, 3, 4, 5. So if I do this, if you see, there are scan count is 5 and logical reads are 15. Is this visible, right? Do I have to zoom or anything? No? Okay. Okay, so it's doing the scanning the table 5 times and logical reads are 15. But if same thing I write with the member number between 1 and 5, then any guess how many scan count will be? 1, pretty good. Okay, so 1 and logical reads are just 3. But these are just consecutive number 1, 2, 3, 4, 5. So you can easily put that between 1 and 5. But sometimes when somebody describes you that you have to write a query to bring member number 1, 3, and 5, our usual approach is write in condition like member number in 1, 3, and 5. So if you write this way, so this is going to scan table 3 times. If you say scan count is 3 and logical reads are 9. But instead of that, if you write the query like this, between 1 and 4 and member number not equal to 2. So if I run this query now, what do you think, what will be the scan count? Still 1. That's good, pretty good. So it's going to do the scan count 1 and logical reads are 3. So you can still, that usual approach is always, we go with in, right? So instead of that, you can write the between. So here is little bit complex. Suppose if you have 1, 3, 5, 6, and 10, so you can write there is a scan counter 5 and logical reads are 15. So instead of that, you can write a query like this member number between 1 and 10 and not equal to all those. So in that case also, it's going to scan the table only once, because SQL Server is bringing data from 1 to 10 and then filtering it. That's why we have just one scan count. Or you can use the just instead of not equal to on all member numbers, you can write not in as well. So that is also going to do the one scan. Or you can use the not between as well, and that is also going to do the scan count as 1. Even if you do go a little bit, oh, this is 10, so I don't know, okay. So this is also do the scan count as 1 and logical reads are 3. Even if you go a little bit higher number, then also it doesn't, it still gives the better result than the in condition. Here if you see the logical reads are 7, which was for just 3 values, it was like a 9, and 5 values, it was 15. So even if you go a little bit higher numbers, that also helps. So whenever you query, whenever you specify in condition, and if you have some close by values, you can write between, and you can use the between, so you can get the better performance. So this is just a logical reads 3 and 9. It's not that much, but if you have a bigger table, and if your queries are running very frequently, then this is going to help a lot. Okay. So yeah, whenever you see that there is an in, you can always consider using between.
About a values set instead.
Values what? Sorry.
Using a values set instead of uniform.
Using the value set.
Yeah.
Like I didn't get it.
Where you would do an inner join on values.
Oh, inner join on the values.
Yeah.
That's I think also going to scan multiple times, because it's just like a number of rows, right? Join.
Make a derived table, right?
Yeah, derived table. Yeah. Yeah. So it's still going to do the multiple scan, I think. It's not a range. It's a 4 or 5 values. It's just like in actually. You are not doing the from to here even if you specify those values. Yeah. I haven't tested it, but that's what I think so, because it just in also it's like that 1, 2, it's at a result set, right? 1, 2, whatever it is. Just like a values if you specify, that's also going to be a result set, and each time it needs to join there. Rather than the between it's a range. That's why it's getting we are getting that less scan count. Okay, good question. Any other question? Okay. So let's talk about the implicit conversion. Okay, so explicit conversion happens when you specify that convert or cast in your query. But in implicit conversion, that happens automatically whenever you have in any equation, whenever you have 2 different data types, like if you are comparing small integer with integer or varchar with integer, SQL Server automatically converts it, and it is not visible to user. So that conversion happens based on the data type precedence rule. So I will show you the order. So whenever you have 2 different data types in an equation, then the data type with the lower precedence, that will be converted first into data type with higher precedence. So if you are comparing integer with varchar, so varchar will be converted first to integer, and then it will be compared. So during that comparison, that SQL Server engine ignores the indexes. So let's quickly look at the demo for this one. So here is an example. Okay, so let me switch on this one, and oh, I haven't started the load. Okay, let me quickly start the load here. So let me reduce I forgot to start the load. So I am running this USB XZ performance testing is tuned equal to 0. So let me show you that performance. So each tune equal to 0 means it's going to run all untuned SPs, like here is the is null. And so it's going to run all, whenever I pass that each tune equal to 0, it's going to run all untuned SPs. And whenever I pass each tune equal to 1, it's going to run all tuned SPs, tuned queries. So let me, I should have started it in the beginning of my presentation, but I'm just, instead of 25, now I'm reducing iteration to 20. Okay, so let me, and here is my database. Okay, so let me start the load. So I'm using that SQL query stress to run the load. Okay, let's keep it running. Okay, so on a, okay, we were on implicit conversion. Okay. So, so whenever you have different data types in your equation, at that time that implicit conversion happens, and SQL Server automatically does it. So here I am just simple example. So I am declaring variable I as integer and s as small integer, and I'm just writing one simple select one where I equal to s. So when I do that, so if you see on a filter, so it's just the, if you see the in a bottom that convert implicit, so it's converting small integer into the integer. So that's why that's how it happens. And here is that order. So this is the highest and this is the lowest. So if you see the small integer is here and integer is here. So that's why small integer converted into the integer first. Okay. So so let me show you that this is the charge column, and this has a charge code, which is charge code that is character 2. Okay. So instead of character, if I declare this as end char and run this query, select start from charge where charge code equal to charge code variable. So if I run this query, so this is going to do the index scan here. And recently something changed in our execution plan on Azure Database. So it's not showing the convert implicit here. So for, I've seen this in my 3 of other demo queries as well. So for this one, I'm going to use my local instance actually, because it doesn't have that what actually I want to show. So I'm on a local instance. I also have a similar database. So let me quickly run this one again. So if you see the index scan here, and if you see that convert implicit, and it's converting a column, that charge code column into the end char 2, and then comparing with the variable, and because of that it is doing the index scan. Okay, now let's try with the because if you see the end char has a lower precedence than integer. Oh yeah, so here is a end char. Oh, so char has a lower precedence than the end char, so that's why char, that column is converted into the end char. Now if I declare the end varchar, that is also going to do the same. If you see here, index scan, convert implicit, and it's converting into end char. Okay. But if I declare the same variable same as column, then it's going to do the, now it says index seek, and if you see here, it's 424 rows only. In this case here, it was, I think, if you see here, it is 10 million rows, so which is very high. So okay, so it's always better to match the data type with the variable data type with the column data type. Okay, so here is another example. So in that case, I am comparing provider number here. So provider number is integer. Okay, and I am declaring this as a varchar. So if I run this one, so this is still doing the index seek, because if you see the convert implicit, it is converting the variable into the variable into the integer and then matching. So if it is right conversion happening on a right side of the equation, then it won't, we don't have to worry about that because that happens just once only. But if it is happening on a column, that's going to happen on for all the rows. So that's why it is that's when it's degrade the performance. Okay, so recently I worked on I'm still working on that project, and they have a just 35 GB database, and they have a deadlock happens every 5 minutes on a just 35 GB database. So I was keep looking, and finally I found that all the ad hoc queries coming from application that has a n-varchar parameter declared. So whether it's matching with the date or integer or whatever it is, everything is n-varchar. So a lot of implicit conversion happening, and that is causing a lot of scanning, and that's why it gets locked, and that's why we are getting deadlock. So that project is still going on. Tragedy is they are not able to find some of the queries in their application. So, okay. So for implicit conversion, it's easy to fix. I mean, whether you can just match the data type, and you can solve the problem. And if it is a conversion is happening on a variable side, then you don't have to worry about. Okay. Any question? You guys are so quiet. Is it so clear or not? It's not clear at all. Very. Okay. Yeah. I kept some question for some cushion for questions actually. So maybe we will finish early then. Yes.
In these examples, we have a clustered index on a column.
Clustered index on a code.
The column that you were using.
Oh, that.
Do you have a clustered index on that?
Oh no, on that charge code, you mean?
That provider number, let's say that one. Do you have an index on that column for that table?
No, actually. It's not a cluster index. I can just quickly check. So cluster index is on a charge number. So on a provider number, it's just a non-cluster index. Yeah. Okay, so let's move on functions in where clause. So I have attended, some sessions on a performance tuning, and I always none of the session ends without talking about the scalar user-defined function. So I also included briefly about in my presentation, but then if you attended that Bob and Connor if you attended the keynote on a Wednesday, they mentioned about the scalar user-defined function. You just have to change the compatibility level to 150, and there is no problem with the scalar user-defined function. But we still have time to change the compatibility level, so I can still go over and talk about it. So in this topic, I'm going to talk about a little bit about user-defined function, then inbuilt function, and how to avoid the function to get the better performance. So let's look at the demo. Okay, so here I am select start from charts where I'm using the two user-defined function here. So there are two types of functions: scalar user-defined function and table-valued function, and both have inline and multi-line code. So function has, one major benefit is it allows modular programming. So you create once, keep it in your database, and then you can call it multiple times from your stored procedure. So that's why we use a function. So here I have created a UDF year and UDF month. Let me show you. So this one is scalar user-defined function. So I'm passing date as a parameter, and it's going to return year for that date. And this one is for return month for the date. So if I run this query, so this takes, I'm going to stop after 5-6 seconds. So let me stop it. It takes more than 30 seconds actually. And I do have execution plan for this one. So let me show you. So here is an execution plan for this one. And if you see here, it's scanning all the rows actually. Even if we have a where condition here, year 2019 and year 3, still scanning all the rows. So whenever you use the multi-line scalar user-defined function, it calls that it gets called for each and every row written by the query. So that's why it takes so much time to return the data. So instead of that, you can use table valued function. So here I have created two, instead of scalar user-defined function, I have created two table valued functions. So create this one, and it's returning the month as a table and returning year as a table. So two table valued function, and both are inline. So if I use that one, then it returns results it very fast, because for table valued function it just calls once only, while for scalar user-defined function it calls for each and every rows. So whenever you have sometimes we don't can't avoid scalar user-defined function, but you can try to convert that into the table valued function. Instead of returning the individual value, you can return it as a table and use that in a query. So that helps a lot actually. Okay, so let's talk about the inbuilt function. So when you describe any developer requirement that said bring all the transactions occurred in year 2019 and month of March, then most of the time developer comes up with the query written like this, that for where charge was year of charge date equal to 2019 and month of charge date equal to 3. So most of the time you see this kind of query written. So if I run this query, so if you see it's on a charge table, it is scanning the table. If you see here, so for actual number of rows is 7 and number of rows read is 10 million or something. So it's doing the index scan here. Okay. So instead of that, if you write the query like this, suppose here it's a charge date between March 1st and less than April 1st. So instead of writing this year or year and month function, if you write the query like this, then it's going to do the index seq. And if you see here, it's going to read just 7 rows. So this is much faster than the queries that with the year and month function. I have to keep checking on my load, sorry. So this one is still going on. Okay. So, but here what we did was we hard coded the. Let's see this side. So let me move a little bit here. So in here, what we did was hard coded this value that 1st March and 1st April. But suppose we just have it at two parameter like year and month. So here I have declared year as 2019 and month as 3. And I'm evaluating the from date and to date based on that one. So if I run just this one, it's going to return March 1st and April 1st. And when I run this query, so if you see the execution plan, it is doing the index scan here. If you see here, so what is happening here? So when I submit this batch, at that time that from date and to date values are unknown. So when at at this point. So that's why SQL Server engine creates the generic plan. So that's why it's doing the index scan. But suppose if I give the option recompile hint here, so then what is going to happen? So if I submit the batch, initially when it's compiled, it's going to be value will be unknown, but when the batch starts executing, this from date and to date value will be evaluated by the time, so that it will have actual value. So this option recompile hint, that is going to take that whatever the value evaluated by this code here. So if I run this query, then it's going to do the index seek. Okay. So we don't use option recompile on every query. We cannot do that. So that has an extra cost as well. So let's try similar thing with the store procedure. So I have here from the same code, everything is same, but it is a store procedure, and I am passing year and month as a parameter. So let me create the store procedure. I think it's already there. Okay, and if I run this query, this is still going to do the index scan. Yes.
You prefer to use between for date comparisons on that?
Oh yeah, that's it's both are same. It used to be not same in a very old version. That's what I heard, but it's between or that greater than equal to and less than equal to are the same. Yeah, good point. Yeah. So if you this is even if it's a store procedure, it is still doing the index scan. But let's write a store procedure like this. I'm passing the from date and to date parameter, and I am just doing this select star from charge where charge date between this. Okay, so let's create this procedure. And if I run the, if I pass this these two parameters, March 1st and April 1st, it's going to do the index seek. So whenever you evaluate the variable inside the store procedure, it's going to create the generic plan. So that's what we do sometimes to avoid the parameter sniffing. But I prefer this way. It's you can pass you don't evaluate the variable inside the store procedure, so you can get the better plan. Okay. Any question? No? Come on. We can talk about something else then. Anyone playing fantasy football this year? No? Okay, good. Okay. So, yeah, and even say suppose we passed, even here also we passed the hard-coded value here, but you can directly say suppose you will have the from date and to date value here, and if you run this SP, this is going to do the index seek. So just avoid the evaluating variable inside the store procedure. Okay. One way that helps in a parameter sniffing issue, but I don't know, I prefer this way. Okay, here is another example of that using function over the column. So suppose somebody describe you write a query to bring all transactions occurred in last 5 days. So sometimes you see that query written like this, select star from charge where date add, we are adding 5 days to the charge date and comparing with the get date. So what we are doing is we are adding 5 days to the charge date and comparing with the get date. So if you run the query like this, then it's going to do the index scan because we are using that function over the column here, that date add function. So instead of that, what you can do is deduct the 5 days from the get date and compare with the charge date. So leave that charge date alone. So that way, if you do this way, you can get the index seek. Okay. Here is another example, a very well-known example. If you have to bring all members' names starting with BAN, then instead of writing substring, you can write the like. So if you write the substring, this one is going to scan the table. But if you write the like here, last name like, so if you don't add any function here, then it's going to seek the it's going to perform the index seek. So the point here is leave that charge date or any column that is, without any function, just leave that alone. Okay, this is still going on. Okay. Okay, so far we looked at the scalar user-defined function. That runs for each and every row written by the query. So that's why it's very slow. Whenever you have, if it can be replaced with the table valued function, better go with it. Most best scenario, you can avoid the user-defined function, and also on a inbuilt function, you can avoid to use over the column. Try to use on a variable side. So that way you will get a much better performance. Any question? Okay, good. Okay, so let's move on a derived table. Okay. Okay, so derived table it's just a select statement inside the select statement. It's just an interim result set. Here is an example. So if you select star from member where left join, this part is called derived table. So when sometimes if you have that multiple steps in your store procedure, try to combine that into one, put that everything into one using the derived table, and that helps a lot in performance. So let's quickly look at the demo for the derived table. Okay, this one and this one. Okay, so you must have seen this kind of query in your environment, like similar looking queries, like all column queries, where it says everything is same except that mean, max, average, and sum. So when I run this query, so this is fine. It's going. So if you see here, it's on a chart that scan count is 172 and logical reads are 5, 6, 2, 7. So instead of, this time what we are doing is scanning the charts table multiple times and bringing this mean, max, and average amount. Instead of that, you can bring this all the rows at once here, like mean, max charts using the derived table, and that use in that main query. So that way you save a lot of scanning. It's similarly on a payment table. On a payment table, I have just one value here, so it's not going to affect that much, but on this one, it's going to help a lot. So instead of writing query for each and every for everything, you can combine that into the one. So if I run this query now, so this one has, if you see that scan count has reduced, it was I don't know 170 or something, it's get reduced to this much. So this way you can use the derived table. Here is another example. Sometimes you see here as I'm bringing a member-wise spending on groceries, meals, travel. So these are all similar looking queries except this parameter, that category description is this. So instead of writing these all column queries, what you can do is, let me just run this query. So if you see here, this has a 384,000 of logical rates and scan count is 63. So instead of that, what you can do is you can bring everything into the one here as a derived table and then use it. So if I run this one, and so this was I think 384,000, right? Now it came down to 54,000. So that helps a lot in if you have some queries running that is very frequently. Okay, so coming back to slides. Okay, So derived table resides in memory. It's not 100% true. When our table is big, I mean, it spills into temp DB as well. And you can, I mean, basically you can, if you have multiple steps in your query, you can just put into one and get all the values at once. So that way you can get the better performance. Any question on derived table? Yeah. Same thing, yeah. Yeah. It helps actually, as long as you use the everything at once. Yeah. Instead of all the column queries, if you bring everything at once, that's the same thing actually. Yeah. Thank you. Okay. So let's talk about table variable, temporary table. So derived table is just within a select statement only. But sometimes if you have worked with the large result set, if you have to store the intermediate result set and use that further into the store procedure, then we use temporary table or table variable. And I have seen that sometimes when you troubleshoot the performance problem after looking at so many things like wait states and blockings and long-running queries and CPU intensity queries, sometimes you end up with one query and that has a table variable or temporary table. So in this topic, I'm going to talk about the factors involved in choosing between table variable and temporary table, and we'll demonstrate some simple rules to get the best performance. So table variable, as we know, we can, just like other variable, we can declare using the declare statement. And just like a temporary table, table variables are available within a batch they declared in. They are not available outside the batch. So if you declare a table variable in a store procedure, it is not available outside the store procedure. But in a temporary table, that is not the case. It's available outside the store procedure as well. You can use create a temporary table in one procedure, that you can use it in a different procedure. So table variable, they are not fully logged. So creating them and filling them is faster. And also table variables, they are not affected by the commit or rollback transaction. So if you begin the transaction, insert some data into the table variable, and if you do the rollback, you will see still data there. So they are not affected by the transaction, while that's not the case with the temporary table. And the main point is SQL Server does not maintain the statistics for table variable, but that is a big point. And we will see how that affects the performance. While on a temporary table side, you can create indexes, you can create multiple indexes. It performs better with the large number of rows. We will see that. And SQL Server maintains the statistics for table, temporary table. Okay, so let's look at the demo. Okay, so this query looks a little bit complex, but it's just from that derived table query, so it's not that. Okay, so here, let me check so this one is completed. It took around 26 minutes. So let me start again with this value 1. So 1 is, it's going to run all the tuned queries. So let me start that one. Let's keep it running. Okay, so here I am declaring a table variable, and it has all columns, and then inserting data into the table variable and using that table variable here. So let's see, let's run this query. Okay. So if you see the first execution plan is for that insert into that table variable, and if you see the second execution plan here, if you see the table scan on a table variable, and if you see here, so if you see the estimate number of rows, that is 1 here. Yeah, so that means its actual number of rows is 83,000 and estimate number of rows is 1. So whenever SQL Server sees the table variable in your query, it assumes that it's going to return just 1 row. So and based on that, it prepares the remaining plan. So it chooses here the nested loop. For 83,000 rows, I think nested loop is not the better option, but it chooses nested loop because it assumes that it's going to return just 1 row. So let's okay. So when you see this problem, so what you can do is you can say, suppose if you put the option recompile, and let's test this again. And we didn't look at how long it ran. So if you see, it took around 7 seconds. This table variable query took the 7 seconds. When you put the option recompile hint and run this query, so it's also going to take same 7 seconds. And if you look at the execution plan now on a table variable here, if you see the estimate number of rows are 83,000. Because when you submit the batch, the table variables, when SQL Server engine compiles this batch, table variable is empty at first point. But when it starts executing this option recompile hint, that is going to force recompile only this last statement, and that state by the time table variable will be populated. But option recompile hint, it's not helping here. It's taking same 7 seconds. So let's try similar thing with the temporary table. So I'm using, instead of table variable, I'm using the temporary table. Similar code, just temporary table. So if I run this one, so this is taking just 4 seconds. That earlier query was taking 7 seconds. And if you see the execution plan here on a table scan, and if you see here, that estimate number of rows are 83,000. So it's matching with the actual number of rows. So because SQL Server maintains the statistics for the temporary table, that's why we see that similar number of rows here. And it's taking 4 seconds. It's performing better than the table variable. Now let's try the similar query with just top 200. So it both has a same, it's the same query, but I'm trying just top 200 only. So let's run this query with the for the table variable. And if it's going to be a same thing, it's 200, and estimate number of rows are just 1 here. And so it's returning almost in a less than a second, 0 second for a table variable. And if I run the same query, top 200 for temporary table, so this is taking 1 second. If we, if you look at that, this is taking little more than the table variable. And if you see the execution plan here, so this one is estimate number of rows are same. So because SQL Server maintains statistics. So so for the larger result set, temporary table performed better. It was taking 4 seconds compared to 7 seconds by table variable. And for a smaller result set, table variable performed better. It took just, I don't know, it's milliseconds, and temporary table one took the 1 second. We can exactly look the maybe in a millisecond, this one. So it's what? Where is it? Almost 1.5 seconds. While that table variable one, let me run this one more time. So this one took just the, I don't know, 31, or this one, 181 millisecond. So for the smaller result set, table variable performs better, and for a larger result set, temporary table performs better. Let's go back to query. Just to summarize, so table variable, I already said that table variable performs better for the smaller result set, while the temporary table performs better for the larger result set. And main thing is SQL Server does not maintain the statistics for a table variable, and that's why we saw that there is a 1 in a estimate number of value. So I recently found that that has changed actually. I don't know how to still have to explore, so let me change the connection to my Azure, this one. Okay, so this one is, this load is completed, and it's, so I didn't store that one. That one took around, I don't know, 25 minutes or something. Let me save this one. Okay, and now let me lower that this pricing tier here. That this was 400 DTU earlier, so let me bring down to 50, and okay. Okay. Okay, so once this is done, I will run this load again, and meanwhile we can move on next step. So it's still doing it. Okay. Please remind me to run that load in maybe 1 minute or something, in case I forget. Okay, so let's talk about the distinct performance impact. So we all use distinct to eliminate the duplicate rows, but sometimes we use unnecessarily. I have seen the developer writing, when they start writing the queries, they write like select distinct without writing any from or where clause or join or anything, just write select distinct. So that's not a good idea. So whenever you use distinct, SQL query engine sorts that result set and then return the unique values. So in this example, we will see when exactly distinct triggers the sort operation, and when we can avoid, even if you use distinct, how we can avoid the sort operation. So let's quickly look at the demo, and I don't know if that one is completed then. So it's 50 DTU, so let me start the load again before I forget. So I changed the pricing tier from 400 DTU to 51. So let me start the load again here. Okay, good. Okay. Okay, so here I have a member table. I just want to change the connection to my local because that I have lowered that pricing tier. Okay, so here I have a member table, and this one doesn't have any unique index. There is a cluster index, but there is no unique index here. So if I run the select star from, let me switch on the execution plan, select star from member where member number less than 20,000. So this is a simple query, so it's not doing any sort operation because I'm not using any distinct here. When I use distinct, so there is a sort operation, and its cost is 84% because SQL Server needs to sort the data to return the distinct values. Okay, if I run the query, similar query without all column names except the member number, that's also going to do the sort operation. Okay, but here I have one more table, member one, similar, I copied from the member table, and I have a unique index on that table. So this one is unique index. That member number has a unique index. So if I run the select star from this one without distinct, that is fine. That is just normal query, so it's not going to do the sort. But if I write select distinct here, even there is a distinct there, it's not going to do the sort operation. So whenever you have a unique index on a table If you do the select star, it doesn't do the sort. It doesn't require sort. It uses that index to return the data. So that's why it doesn't do the sort. So you can. So it's always good to have a unique index on a table. So if I this is the query without the member number. So in that case, it's going to do the sort here because there is no member number here. If I add the member number here, and run this query, this is going to do the what? Testing. Oh yeah. Even if I add the member number, it's not going to sort the data because it has a member number in it. Without member, it's going to sort the data. So without member number, it's sorting the data. Okay. So, I mean, if we have to, I mean, we use distinct. Everyone uses distinct to eliminate the duplicate rows. But if we have to use distinct regularly, that means there is some problem with either with your database design or query. Maybe your query is inefficient, or both could have a problem. So in that case, you have to look at your database design. You have to make sure that has a unique primary key. Basically, you follow the normalization rule. Okay. So distinct invokes the sort operation, and we saw how to avoid that. Okay, that one is still going on. Okay. So next one is this is I think last one, lookup table with and without index. So lookup table, very small table. Sometimes they be used just for a drop-down purpose, and we don't care about the index on a lookup table. Here is a category table is an example. So we just ignore. Even if you scan the table, it's not going to make any difference. So that's why we don't create the index on lookup tables. Sometimes we ignore it. So let's see how that affects actually the performance. Okay. So let me open that lookup table. Okay. So here is this one and this one. Okay. Here I have a category table, and that has a index on it. And so here I'm just using that temporary table because just I don't want to result too much data into my result set. So I'm using select star from charge where joining on a category that is lookup table, and this category table has a index on it. So let's look at the execution plan. So it's doing the indexing, and if you see, it's doing one row, and if you see on a category table, it's doing the just logical reads are just 2 here, because category table has an index at the moment. Now, if I use the similar query on a category 1, let me show you the category 1. Oh, come on. So there is no index available, so that's why it's returning direct this one. So category 1 doesn't have an index. Category that has a index, category number. So if I use the category 1 instead of category here, so let's look at the execution plan on a category 1 table. If you see here, that's 74073 actual number of rows, and if you see the scan count here, that is like 74073, even on a just 15 rows table. So we sometimes easily ignore. That it is a small table. Why do we need the index on this one? But that can impact the performance. So if I do the same thing on a smaller result set, it works fine. If you see here, on a category, if you see T46 with the category table which has an index, and if I do the same with the category 1, this one is giving a little bit more logical reads. But most of the time, if you have a larger result set, then it is better to have index on a lookup table. Even if it's a 10 or 15 rows table, it's good to have an index on that one lookup table. Okay. So let me quickly check where are we? Oh, it's just 6 iterations to go. Okay, we have 3 more minutes. So, okay, maybe I can. So do you have any question? We can talk about any question. Any overall any question other than this topic as well? Yes.
So implicit conversion.
Yes.
Can you explain again how could you avoid it?
Oh yeah, okay. So you just have to match the data type actually. So let me open that implicit conversion. Yeah. So here, if you say here a charge code, that is if you declare a char, it's if you match the data type with the column. So charge code is character 2, right? So if you just have to provide the same data type, and or if you have sometimes if you have a correct conversion happening on a right side on a variable, then you don't have to worry about because you're not converting the column. So all the rows. Yeah. So that way you can avoid it. Any other question? So we can just estimate it. So on a first one, I think took around 25 minutes. That first load, that took around 25 minutes. Then second load, I have that one I have here, so I can quickly look. I choose this one. So that one just completed in 1 minute and 54 seconds. That is with the tune queries, and this one is still it's 17 iterations are run, and it is taking around 9 minutes. So first one is 25. Then if you compare with this one, this is taking. So let's consider this is going to take 10-11 minutes. So it's 50%, almost more than 50% better than the earlier one, and we saved. Let me show you how much we saved with how much money we can save. So initially it was $50. 50 DTU is $75, and I was at this one, so that was $600. So we can save $550 per. Then this is just sample database. So if you tune your query, you can lower your monthly spending. Okay. So thank you so much for coming over, and this is my contact information. If you have any question or anything, you can reach out to me for anything. Thank you so much, and have a great day.